Today we'll be starting section 10.5 about sine and cosine, but before we do that, we will review tangent again. Tangent's what we've been working on for a few days now. Tangent deals with which two sides of the triangle? Opposite and adjacent. We do not use which side? Okay, tangent does not use the hypotenuse. So if we are finding the tangent of angle A as a fraction, it would be what over what?
21 over 8. 28.
Jaden, what is the tangent of A? 21 over 28. And we notice that that fraction can be simplified to 3/4. All right, this says to find it in fractional and decimal forms. What is 3/4 as a decimal? 0.75. Okay, it also asks us to find the tangent of angle B. I'll do that below. Who can raise their hand and tell me the tangent of B? Keon. No. Thank you, Martez. We cannot use the hypotenuse. So it would be 28 over 21, which reduces to what?
4 over 3.
4 over 3. As a decimal, that would be 1.3 repeating. Martez? Now is not the time for that conversation. If we get through notes, we can have that conversation. All right, now we are going to have to figure out what the angle measures are. Angle A and angle B. Let's start with angle A. We have already got this tangent of A is equal to, and you can use 21 over 28, 3/4, or 0.75. It doesn't matter which one you use. I'm going to use the 3/4 to set up an equation. We don't want to know what the tangent of A is anymore. We actually want to know what angle A measures to be. So how do we get A, capital A, by itself? No. Take the inverse. If you're trying to find an angle, that's when you use the inverse. So we use inverse tangent on both sides. Again, your table is not necessarily going to help you in this unless you become very familiar with how it works. So I would still have a calculator to help you with the inverse tangent. Inverse tangent is not on that table. So we use our calculators. We type in inverse tangent of 3/4. And what do we get? Okay, it says to round to the nearest tenth, so what would it be? 36.9 degrees. So we could fill that in our triangle. 36.9 degrees for angle A. We still have to find angle B. You could use inverse tangent again, or what's the shortcut? Good. Subtract from 180. 180 minus 90 minus 36.9. What would that give us? Connor? 53.1 degrees. On the second warm-up, we are starting over. Same steps. We have to find the tangent of angle A. Who can raise their hand and tell me the tangent of A? Angel? What over what? That would be for B. So the 30's across from A, so opposite is 30. That goes on top over the adjacent is the 16. What does that reduce to?
15. That's not right.
Okay. We've got tangent of A as a fraction. We don't yet have it as a decimal. What would 15 over 8 be as a decimal? Good, 1.875. So we'll set that aside for now, and we'll also find the tangent of B. If you're finding the tangent of the two not right angles of a triangle, they are always going to be reciprocals of each other. So the tangent of A is the reciprocal of the tangent of B. So if you already found the tangent of A, you can just flip it upside down, and that's going to be the tangent of B. It, as a decimal?
Yeah.
What's it going to be?
0.53 is 1.53.
Okay, 0.53 repeating.
Yeah.
Good. The last thing we have to do is figure out what those angles actually measure to be. So in order to do that, what function do we have to use? Not just tangent. Inverse tangent.
For both of them?
Well, that's up to you. You can either do it on both, or once we find one of them, we can subtract from 180. So the tangent of A is equal to 15/8. I use the inverse tangent on both sides in order to get A all alone. What do we get? Rounded to the nearest tenth? Good, 61.9 degrees. So that's for angle A. And then in order to find angle B, either you can use inverse tangent again with your tangent B, or you can just subtract from 180. Keon? 28.1 degrees for angle B. Our objective will be to use sine and cosine functions. We are going to use the other two trig functions. Use sine and cosine functions. All right, so today we're talking about sine and cosine. Sine is usually written as S-I-N. Cosine is usually written as C-O-S. These ratios involve the hypotenuse of a right triangle. The ratios are always between 0 and 1. So you will never have an improper fraction. Like on the warm-ups, we saw one where it was 15 over 8. That will not happen with sine and cosine. There'll always be a fraction between 0 and 1. Okay, when we're taking the sine of an angle, we are talking about the opposite side over the hypotenuse. So the side opposite the angle over the hypotenuse. For cosine, we talk about the adjacent side over the hypotenuse. So if we're looking at this specific triangle that we have, I would recommend possibly putting this in the margins. If we're looking at this triangle and we're talking about finding the sine of angle A.
What
If we're talking about the sine of angle A, what side is opposite angle A? Side is opposite angle A. Little a. Okay, and then over the hypotenuse. Which side is the hypotenuse? Little c. Okay, if we're talking about the cosine of angle A, what side is adjacent to A? It's B. So obviously we know the hypotenuse is going to be what? C. The hypotenuse is C on these. The hypotenuse does not change. If we're talking about angle A though, if C is the hypotenuse and A is opposite, the only option we have left for adjacent is little b. Usually the adjacent side is the hardest one to identify, so I would identify the others first. And then whatever's left over should be your adjacent side. Okay, let's try this again using angle B. What is the sine of B for this triangle? What's the opposite side from B? Little b. Over the hypotenuse? Still C. Okay, then we talk about the cosine of B. What side is adjacent to angle B? Little a. And the hypotenuse is still C. Here's a mnemonic that might help you remember this. Some old hippie came a-hopping through our apartment. Now, the other phrase that we learned when I was in school, you might have heard someone say it before, is SOHCAHTOA. Anybody heard that? Yeah. So I learned just to use the letters, sine, cosine, tangent. However, it's going to help you remember it. Somebody apparently likes the phrase, some old hippie came a-hopping through our apartment. If you like that one, that's fine. I always use SOHCAHTOA. It just uses the letters. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. They use the same letters here. SOHCAHTOA. They say use the same letters, they just made a phrase out of it. If you want to make your own phrase out of SOHCAHTOA, go for it. All right, these first couple examples, all we have to do is find sine, cosine, and tangent of both angles A and B. If we're finding 3 trig functions for 2 different angles, that means we should have a total of 6 statements as part of our answer. So I'm going to be not calculating, but identifying the sine of angle A, the cosine of angle A, the tangent of angle A, sine of angle B, cosine of angle B, and tangent of angle B. Sine is what over what? Opposite over hypotenuse. What side is opposite angle A? 4. And what side is the hypotenuse? 5. For the cosine of angle A, we want what over what? Adjacent over hypotenuse. What side is adjacent to angle A? 3. And our hypotenuse is still 5. For the tangent, we want what over what? Opposite over adjacent. What's the side opposite of A? 4 and adjacent, 3. Questions about sine, cosine, tangent on angle A? All right, what about sine of angle B? Good, 3 over 5. Cosine of B is 4 over 5. And the tangent of B? 3 over 4, good. Sine of A is the same as the cosine of B. And the cosine of A is the same as the sine of B. Okay, that will always happen. Just like for tangent of the two angles, they always are the reciprocal of each other. The sine of one angle is going to be the cosine of the other angle. Sine of one angle is the same as the cosine of the other. That's another thing that always happens. Yes, we have to write all that again for number 2. Right, so if all they ask for is sine, cosine, tangent, that's what we found. That's it. So we're going to find the sine of angle A, cosine of angle A, tangent of angle A. We will also be finding the sine of angle B, cosine of angle B, and tangent of angle B. Who can help me out with the sine of angle A? Six over 10, which reduces to? We're not sure. 6 over 10? 3/5, good. If you just said it, you better say it louder. I'm old and deaf.
I just said that.
The cosine of A. 8 over 10 reduces to be 4/5. The tangent of A. 6 over 8, which reduces to 3/4. What about the sine of angle B? Let's move on to angle B. Now, either you can go back to the triangle and start over, look for the opposite side for B and the adjacent, or the opposite and the hypotenuse again, or if you remember the pattern, the sine of B is going to be the same as what? Cosine of A. Those are going to be the same, so it's going to be 4/5 again. The cosine of B is going to be the same as the sine of A, so it would be 3/5. Tangent is not the same as anything, but it is the reciprocal of the other tangent. So that switches it to be 4/3. All right, who can tell me the sine of A on number 3? 15 over what? Okay. 15 over 17. That's going to be the same as which other one? Cosine of B. So we can go ahead and fill that in. 15 over 17. What about the cosine of A? Eight over 17. Adjacent over hypotenuse. And that's the same as sine of B. So we'll fill that in. What is the tangent of A? (15 over 8), which makes the tangent of B 8 over 15. Number 4, the sine of A. Opposite over hypotenuse. What side is opposite A? 9. Over the hypotenuse is 41. The sine of A is the same as which other function? Cosine of B. All right, what about the cosine of A? What side is adjacent to A? 40, and the hypotenuse is still 41. Sine of A is the same as which other function? Sine of B. So 40 over 41. What is the tangent of angle A? 9 over 40, which makes tangent of B 40 over 9. All right, this next set of examples is when that sheet that I gave you could come in handy, or you can use a calculator. But if you don't have a calculator with you, that sheet will give you the answers to these questions. This time we are given degree measures. They didn't put the degree symbol on these, but these are meant to be degree measures of angles. So we are finding sine, cosine, and tangent, whatever it is that they asked us for. The numbers in front are the numbers of the problem. Don't start multiplying by those. Okay, so these are just numbers of the problems. So if you're using the sheet, you need to find 68 degrees, which is in the left-hand column. The bold numbers are the angle measures. Find 68 degrees and slide over to the sine column and see what number that is. Or, if you have a calculator, you can just type sine 68, enter, and it will give you that value. You will just have to round it to the 4th decimal place. So what are we getting for the sine of 68 degrees? Anybody find it? 0.9272. And then we're done. If that's all they asked us for, that's all we got to do. Okay, then we change it and we do the sine of 48 degrees. Again, if you'd rather use your table, you can do that. 0.7431. Good. We're switching to cosine now. So we're looking at a different column or using a different function on our calculator. It's the cosine of 68.
0.3746.
Good. 0.3746. The cosine of 48. 0.6691. I would agree. Finally, on the last one, we're using tangent. So again, this is a different column of values if you're using the table, or a different function if you're in your calculator. What's the tangent of 68?
2.4751.
Wonderful. All right, on number 10, we are going to be finding the lengths of both of the legs of this right triangle. So all we were given is a degree measure and the hypotenuse of the triangle. Now, to start this problem, you get to choose which trig function you want to begin with. Okay, if we are only given the hypotenuse and an angle, do you think we want to use tangent? A couple of people are shaking their heads no. The answer would be no, because tangent does not use what? The hypotenuse. So we want to use a trig function that involves what we already know. So you tell me, what do you want to use? Sine? Okay, so if we set it up, the sine of which angle do we know? A, what's its measure? Okay, sine of 28 equals, sine involves what two sides? Opposite over a hypotenuse. What's the opposite side? A. And the hypotenuse is 15. When you already know the angle, this is when we put it over 1 and cross multiply. When you already know the angle. So if we cross multiply 1 times A, what do we get? A equals, the other cross product is 15 times sine of 28. Did you use your table or calculate that already? 0 point what? 4694. Do we agree with that as being the sine of 28? Let's check it. Ah. Yes, we would round that up to 4695. Then what's our last step to know what A is? Multiply. 7.0425. Do we agree with David? Okay, if you were to round that to, if we were to round it to the nearest tenth, what would it be? 7.0 or just 7? I know it didn't say nearest tenth in the directions, but that's what we're going to do. To find our last side, we take the cosine of 28 degrees and set that equal to what? Adjacent side would be, what's adjacent to this 28 degrees? B over the hypotenuse, 15. Again, we cross multiply and solve. So B equals 15 times, what's the cosine of 28? No.
It is
0.8829. And then we still have to take that and multiply it by 15. And what do we get for side B? $13 point. We gotta get this one done. 13.2 is correct.